Hi, this is Mrs. Vrobel. This is part 2 of the mole. So in the first video we talked about counting the number of particles that are in matter. And we essentially took the mass that we weighed out in the lab and we converted that to moles. And in that moles, we counted the number of particles, which would be Avogadro's number, 6.02 times 10 to the 23rd. Now today we're going to talk about molar mass of a compound or moles of a compound. And notice that when we're talking about moles of a compound, we essentially want to use the chemical formula. And within that chemical formula, we can convert from mass to moles of that compound. And I'll show you how to do that in a minute here. Now, it's important when you look at a chemical formula, we're talking about 1 unit of the compound. And here's an example of carbon dichlorofluoromethane. And here we have 2 moles of chlorine because of this subscript here. And we have 2 moles of fluorine because of this subscript here. And we have just 1 mole of carbon because there's an understood 1 here. So you always need to look at the chemical formula first before you try to estimate the number of moles of that compound. So in this slide, I want to find the molar mass of sodium hydroxide. In order to do that, I need a periodic table. So I put a periodic table on this slide here just to show you. So I first want to look at sodium. So sodium, when I look at the periodic table, its molar mass is 22.99, and that's grams per mole. Now, I want to also look at oxygen, and notice oxygen is 16 grams per mole. And then lastly, we're going to look at hydrogen. And here, hydrogen is 1.01. So when you add all these up, you get 40 grams per mole. So you're going to do that whenever you have a compound. And like I said, you need to use the periodic table in order to do this. Okay, so then I can take that molar mass that I calculated in the previous slide and I can multiply it by the moles of a compound, and what this is going to give me is mass. So please remember, when you go to the periodic table, you're essentially conserving mass because you're taking the individual atoms that make up a compound and you're essentially adding them all up together to equal 1 mass. Now in this calculation here, I had 2.5 moles of sodium hydroxide. I just multiply it by the molar mass of sodium hydroxide, and as a result I get the mass of sodium hydroxide. Okay, so for this last slide, I really like this diagram because I think it kind of ties together everything that we need to do with counting in moles. So if I was given moles of a compound, you would do what I essentially did with this last calculation, is I would multiply it by the molar mass of the compound. So I would have to go to the periodic table, add up all the different masses for the respective atoms, and multiply that by moles to give me mass of a compound. Now, if I want to go in another direction here, if I had moles of atoms or ions, and I wanted to figure out moles of a compound, notice that I would take that mole of the compound and I would divide it by the moles of atoms or ions to give me moles of compound. And then lastly here, if I have moles of compound and I want to count how many particles are in that individual set of moles, I would just multiply it by Avogadro numbers, and that would essentially give me representative particles. So this diagram, I really like it because it shows you the different directions that you can take with where you're trying to convert or change or calculate, I should say, your units. And if you pay attention to the units, that'll definitely lead you in the right direction for quantifying matter.